Today, we will be solving palindrome number, and we are given an integer x, and that's basically our input, and we have to return true if x is a palindrome and false otherwise. A palindrome is basically an integer in this case, which reads the same forward and backwards. So, for example, if we have 121, it reads the same from both sides. But for example, if we have 123, from the left side it reads 123, but from the right side it reads 321. So it's not a palindrome. And also in the example here, we have we have the same example that we just went through 121, which is a palindrome, and we have in the second example we have a negative number, which can never be a palindrome, since, as you can see, if we read it from the other side, like this doesn't make sense, mathematically doesn't make sense. So that's our first hint, that negative number cannot be a palindrome. And also in the last example, we have number 10, which is not a palindrome because it reads 0, 1, which is just 1 actually, from right to left, and from left to right is 10, so it's not a palindrome. Now, the constraint is that x can be in the range of the integer, so ranging from the minimum to the maximum value of an integer. Now, the straightforward solution would be to convert an integer to string and basically just check if iterate through the string and check if the first character matches with the last, second character matches with the one next to the last, and so on until we reach the middle. But on the interviewer, you will be probably asked to not do that and operate on the number itself. And to do that, well, we have to do a little bit of math. And we will start with the example. And for this example, we will use the number 9,889. So it's clearly a palindrome because we have connecting 9s and 8. How are we going to solve this? So the important part is actually getting, iterating over the number and each time getting the first and the last number, the last digit of the number, and then removing those. So in the next iteration, we can have the second and second to last number, and so on until we reach the middle ground, just as we would do with the string. To do that, we would have to first find a way how to get the first and the last digit. So to find the last digit is pretty simple, because let's say we have 59. To find the last digit, we just do the modulo of 10, because that will return just 9. 59 modulo 10 is just 9, because 59 divisible by 10, if we have integer division, will be 5, and that 5 times 10 is 50. The remainder is 9. So that's the easy part. Finding the last digit is the easy part. To find the first digit, we would have to find the number of the digits that our input number has. And to do that, we will, well, how can we do it? We can use a bit of mathematics. So to find the number of digits, we can use math. We can apply the logarithmic function on our number. It's basically asking the question, how many times can we divide the number by 10? Because if you think about it, like, for example, if we have 535 and we divide it by 10, it will be 53. If we divide it by 10, it will be 5. And if we divide it by 10, because here it will be 0. So it's 3 times until we reach the 0. So there are 3 digits representing the number 5. So we can use the mathematical function logarithm to find the number of digits. So if we have, and also the base is 10 because we are dividing by 10. So this will help us find the digit, find the number of digits. Now to find find the first digit, we can just use this to get our power that we will be dividing by. So, for example, here, if we apply this, we will actually get 3. So it will not be exactly the number of digits. The number of digits will be this function plus 1 always. So so we will get 3, and that's the in this case we can use that 3 to find our base power. And when I say base power, is the number that we have to divide this number with to get the first digit. So to find that, we will use the power function from our math library, and we will use this to get the right power. So in this case, it will be 10 times 10 times 10 times 10, and it will be 1000. So if we divide this number with 1000, we will get 9. So basically, that's it. What we have. For example, if we have 59, this function will result in 2. So it will not be it will result in 1 actually. 59. If we are taking this example, it will result in 1, not 2 digits. So if you want to get the total number of digits, you would have to do +1. For this example, if you use matlog, we will get 2, and then you use 2 plus 1 to get the number of digits. But here, so we get 1, and if we do power 10 to 1, it's basically 10, and if we divide 59 by 10, we will get 5. And for example, here we will get 2. 10 to the power of 2 is 100, so it will be 535 divided by 100 will be 5. So that's how we get our first digit. So after we get our first 2 digits, first digit and last digit, we just compare them and see if they are equal, and then we can move we can move to the middle of the number. So in this case, we first have to take care of the digits, the first and the last digit, and to do that, we would first subtract the remainder the result of the division by our initial base, which is 10, which is actually 9 in this case. So it will be minus 9 times our base, and this will basically be 889. Now we got rid of the first digit, and to get rid of the last digit, so it's basically our remainder after doing the module. So it will be 10, which is equal to times 889 minus 9, which is equal to 880. And the last step is basically to get rid of the 0, and that's easily done by dividing by 10. So the result will be 88. And we can do the same approach that we did with our beginning number. So 88 is close to 59, and we already know how to do that. The base will be 10, and then we will just follow these 2 steps to get rid of the 2 digits, and then we will arrive at 0. So our middle of the number. And if all the pairs match, we know that it's a palindrome. Because we don't have any additional data structure, the speech complexity is constant, and also we only are iterating over the digits, the total number of digits, or the number has. So you can say it's basically constant too. It's some number that we got as an input, or you can say it's proportional to the number of digits of our input. So in this case, if we just logarithmic value of our number plus 1. So let's code up the solution first. We know that no negative number can beat palindrome, so the minus in front. So we will just check if our input is lesser than 0. In that case, we will just return false. First, we will get the number of digits using the logarithmic function. And because all mathematical functions from the math library in Java return double, we will have to do the conversion to integer. And this is explicit conversion. The same goes to the use the number of digits to get our base power. This will be dividing our number width initially to get our first digit. Then we iterate over basically over all the digits, the number by pairs. So it will be first and last digit, second to last, and the second digit, and so on. So if we do that until the number is greater than the remaining number is greater than 0. So if we first to get the first digit, we divide by our power, and to get the last digit, we just do the modulo of the remainder function. And if they are not the same, that means that our current pair is not the same, and we just return false because the number is not palindrome. In case it is, we just have to continue, but to do that, we have to remove the first and the last digit. To remove the first digit, we will just use the power and subtract whatever we get by dividing the current number with power and then multiplying back to the power to get the same digit number, but it will be just the first digit and the rest will be 0. So it will just subtract the first digit from our number. And to remove the effect of the last digit, we just remove the remainder when dividing the current number by 10. And that will also get us to the number that's ending with 0. So to remove the 0, we have to finally divide the current number, the remainder, by 10. And then because we got rid of 2 digits, our remaining number is by 2 digits small, like in the length, which basically means that we have to reduce power by the magnitude of 2. To do that, we just divide by 100. And we do this process until we get to the 0. If at any step we have a number we have a pair that's not the same, we know it's not a palindrome, the number is not a palindrome, we return false. Otherwise, when we are done with the loop, we just return true because our number is a palindrome.